Alright, so the derivative of inverse sine x. Last video I did the integral of inverse sine x, so if you didn't see that, check it out if you care enough. But yeah, in this video we're gonna be taking the derivative of inverse sine x. So alright, so we're looking at this and we're confused. So let's take a step back. If we have y is equal to inverse sine x, we're obviously trying to find dy dx. So we're starting at this now, and it doesn't look like this is going to help. We just wrote the same problem in a goofier way. But pay attention, because I'm about to do something interesting. So if we know y is equal to inverse sine x, we can say that x is equal to sine of y. Alright, do you see what we're about to do? I think what we can do is we can hit some implicit differentiation right here. Guys, I mean, look, if we're going to differentiate with respect to x on both sides, we're going to have one here, we're going to have something times dy dx, because that's how implicit differentiation works. And look, we're going to get something times dy dx, we'll be able to solve for that. If that doesn't make sense right now, well, just keep watching and it's going to make sense. So here, we have x is equal to sine of y. We'll take d dx both sides, right? Differentiate with respect to x on both sides. So d dx is equal to sine of y. I don't really care if this notation is right or not, but you get what I'm talking about, because I'm talking to you in English. Alright, so d dx x equals sine y. On left hand side, the derivative with respect to x. So derivative of x with respect to x, that's just 1. Okay? 1 is equal to. Alright, so right hand side, the derivative with respect to x of sine of y. Well, we kind of don't know that because we're trying to differentiate with respect to x, and we have a y here. So let's take a step back. Let's use a chain rule real quick. So if we want to find d dx of sine y, maybe what we could do is we could take d dy of sine y, and then we can maybe multiply by dy dx, right? So you see here, dy, the denominator, dy, the numerator, they cancel out, and we end up with d dx sine y. It's a sloppy way to work with fractions, but like, this is exactly what we need to do. This is how implicit differentiation works. Alright, so we have d dy sine y. Let's think about this. Remember our table of trig derivatives and whatnot. Let's think about this. Sine becomes cosine. Alright, so d dy sine y, that's just cosine y. Cosine y. And then, well, times dy dx. So you get that. Times dy dx. Okay. Now, well, we need to solve for dy dx because that's what we're trying to find, right? So we get dy dx is equal to 1 over cosine y. Alright, so let's see here. This is not our final answer because we want to find d dx inverse sine x. We got an answer in terms of y. So like, it's probably not, we probably want something in terms of x for everything to make sense. So let's think about this. 1 over cosine y. We can do, we have y equals inverse sine x, right? So you dy dx in terms of x, maybe we could just, plug in 1 over cosine of inverse sine x, right? 1 over cosine inverse sine x. And that's going to get us an answer in terms of x. So one thing you can do, you can just leave it like that and hope that the reader will simplify themselves. Or what you could do is you could rewrite this, maybe using little trig identities, to get a nice, more interesting answer. So let's do, to make the video longer, just for the sake of making the video longer, and to get a more complete answer, we're going to be doing some trigonometry. Let's see, 1 over cosine of inverse sine x. We can use a Pythagorean identity and rewrite this as 1 over the square root of 1 minus sine of inverse sine x, and all that squared, right? Because we know that sine squared x plus cosine squared x equals to 1. I'll write that here. Sine squared x plus cosine squared x is equal to 1. I'll fix that. Alright, so I mean sine squared x, oh actually no, we're trying to solve for cosine squared x, right? Cosine squared x is equal to 1 minus sine squared x. So cosine x is equal to square root of 1 minus sine squared x. Alright, that's exactly what we put in here. Alright, so cosine y became cosine of inverse sine x, that's what our y was, and then we rewrote this using our trig identity, Pythagorean identity. Now look here, we have something interesting. We're taking the sine of an inverse sine. Well, let's see here, sine, inverse function, they cancel out. So we're left with the final answer is equal to 1 over square root of 1 minus x squared. And this is the interesting answer, and this is why we did all this work, because it's kind of interesting how the inverse trig function turned into a polynomial. Right, the derivative of inverse function is a polynomial, rational expression, whatever you want to call it. That's kind of interesting. So the extra 1 minute I probably added to the video was probably worth it. So yeah, pretty cool stuff. And yeah, we'll see you in the next video, whatever that is.